So let's just see the next question. Question number 2 says that find the relation between x and y such that the point x comma y is equidistant from the point 7 comma 1 and 3 comma 5. First of all, what is the meaning of being equidistant? So let us suppose if I'm talking about the point x comma y. So this x comma y is actually equidistant, means the distance of this particular point from these 2 points, that is 7 comma 1 and 3 comma 5 is nothing but equal. So this distance is nothing but equal. So let us suppose if I'm calling the point x comma y as nothing but p and the further points as a, b. So let us suppose, let's just start the solution over here. So let p x comma y be equidistant from a 7 comma 1 and b 3 comma 5. So I have taken this point as nothing but p and I am taking this as a and I am taking this as nothing but b. So according to the question, as being they are equidistant, so it means that the distance of AP is actually equal to the distance of PB. So if I am talking about taking the distance AP and BP, so we can say that AP distance is nothing but is equal to BP distance. I'm taking AP distance is nothing but is equal to BP distance. So if the distances are equal to each other, so we can find the distance using the distance formula. So what is the distance formula? If I'm talking about taking the distance AP, so let us suppose if I'm considering it as x1 y1, this is x2 y2. So the formula should be of the type x2 minus x1 whole square plus y2 minus y1 whole square. So remember, I am taking the coordinates a 7 comma 1 as nothing but x1 y1 and I am taking x comma y as x2 y2. So let's just plug in all the values over here. So AP can be written as a square root of P's coordinates is x comma y, so I am taking x2 as x. So this would be x minus 7 whole square plus y minus 1 whole square. And in the same way, I am taking the BP distance. In the same way, I am taking BP. So BP can be written as, let us suppose I am again considering it as nothing but x2 y2 and this is x1 y1. So if this is x2 y2, this is x1 y1. So the formula would be of the form x minus 3 whole square plus y minus 5 whole square, x2 minus x1 whole square plus y2 minus y1 whole square. So using the distance formula, I can write AP distance and BP distance in this particular form. So let's just sort it out for the values of x and y. So in order to solve it, we have to take the square on both the sides. So let's just take square on both sides. So if we'll take the square on both sides, so this would be of the form square root of x minus 7 whole square plus y minus 1 whole square, which is equal to square root of x minus 3 whole square plus y minus 5 whole square over here and whole square over here. So square and square root get cancelled, square and square root get cancelled. So the only value that we have right now is nothing but x minus 7 whole square plus y minus 1 whole square, which is equal to x minus 3 whole square plus y minus 5 whole square. Now we can apply the algebraic identity, that is a minus b whole square over here. So let's just apply. So this is a minus b whole square, which is a square plus b square minus 2ab, further a square plus b square minus 2ab, further a square plus b square minus of 2ab, further plus of a square plus b square minus of 2ab. Let's just cancel out the values, whatever is cancelling. So as we can see, we have a sign of equality within. So x square get cancelled with x square. Further y square is positive over here. So let's just sort it out. We have 7 square, which is nothing but 49, minus of 14 of x plus of 1 minus of 2 of y, which is equal to 9 minus 6 of x plus of 25. Further we have minus of 10y. This is minus of 10y. Now let's just take the values x and y variables on one side and the constants on the other side. So if I'll take the variables on one side, so it would be minus 14x minus 2y plus 6x plus of 10y, and I'm taking the constants on the other side. So this would be 9 plus of 25. Further we have minus of 49 plus of 5 is 50. So this is nothing but minus of 50. So let's just sort it out. So this would be nothing but minus 14x plus of 6x. So this is minus of 8x plus of 8y, which is equal to 9 minus of 25. So this would be nothing but implies that minus of 8x plus of 8y, which is equal to minus of 16. We can take the negative 8 common, so this would be x minus of y, which is equal to minus of 16. Minus 16 and minus 8 get cancelled with each other because negative and negative get cancelled with each other. If I'll take 8 towards the other side, so this would be x minus y is equal to 16 by 8. 8 into 2 is 16, so implies x minus y is equal to 2. So at the end, what we are getting the relationship in between the x y variable in the formation of x minus y is equal to 2, because the question says we have to find the relation in between x and y. So what is that relation? The relation is actually coming out to be x minus y, which is equal to 2. So this is nothing but the answer for this particular question using the distance formula.